All right, so in this lesson, I'm going to teach you how to find the equation of an inverse relation. So far we've been working a lot with graphing and domain and range and all that good stuff. So in this lesson, I want to focus primarily on finding the equation. Okay, so I want to start off with one statement up here, which is pretty important. The function notation for the inverse of a relation is denoted just like that right there. And that's actually read a specific way. It's called end f inverse. So yes, it looks like a -1 up there. So you might read it as f to the power -1 just because we trained you on that in grade 10, but it's actually called f inverse. So when you see this notation, you should automatically recognize that it's an inverse function, okay? So I wanted to mention that really quickly here, especially in your work text that you're currently working with right now. It doesn't actually tell you about this notation, but I've seen in a few diplomas this type of notation. So I just wanted to show you that it actually could show up somewhere in your diploma or even on your assignment. Okay, so that's just an aside. Let's actually get started with an example here. So I have determined the inverse of this function f of x is equal to 2/3 x plus 4. Okay, so this is obviously in function notation because you got your f of x up here. So rewrite it in terms of x and y. So this is going to be equal to y is equal to 2/3 x plus 4. So I simply just took my f of x and replaced it with a y instead. And the reason why I did it is because you know from my previous lessons to find the inverse of a relation, you just simply switch your x and y values around. So this becomes x is equal to 2/3 y plus 4. Okay, and then from here to find the actual equation, you're just going to solve for y. So if I solve for y, the first thing I'm going to do is bring the 4 over, so -4 from both sides. Okay, 2/3 y, and then I'm going to multiply both sides by 3. So this is just simple algebra. By now you should be pretty comfortable with this. We have on the left-hand side 3x minus 12 is equal to, these cancel out, so I'm left with 2y. And the last step I'm going to conduct here is obviously dividing by 2. So let's divide by 2 and see what we get. So this cancels out. I get y is equal to 3x over 2. You know what? I'm going to leave that as a fraction. And then I have -12 divided by 2, which gives me -6. So there's the equation on my inverse relation, okay? And you want to check, sometimes you can actually express it in function notation. So this is the equation of some sort of linear relation. And as you know from your grade 10 experiences, that every linear relation is indeed a function. So it passes the vertical line test, in other words. So a second way you can express this function is using function notation for an inverse function. So f inverse is going to be equal to 3x over 2 minus 6. So both of these equations are completely valid. I just want you to recognize that on a diploma you could see it expressed in this way. Okay, so let's take a look at one more example here. We're given the, determine the inverse of this function f of x is equal to x minus 6 squared. So we are working with a parabola, and I want you to keep in mind, is the inverse of a parabola a function? Okay, so think about that for a sec. Let's go ahead and move on and try to find the inverse of this function. So rewrite f of x with a y, so y is equal to x minus 6 squared. And then you're going to switch your x and y values around. So this becomes x is equal to y minus 6 squared. Okay, so we want to get rid of the squared first. So you want to take the positive and negative square root of both sides. So don't forget, you got to take the positive negative case of a square root. So I'm left with positive negative x on the left hand side and y minus 6 on the right hand side. The last thing we want to do is add 6 to both sides, and we get 6 plus or minus x. Sorry, that should have been the square root there. Plus or minus the square root of x is equal to the y. Okay, so there is the equation of my inverse relation. A question you want to ask yourself, can we express it in function notation? for an inverse? Can we express it like that? Like I said, you can only use this notation if it is a function. Taking a look at this equation, is this a function if you graph it? Well, we can quickly do a little sketch on the right-hand side here. Let's sketch the original function. Now, this is a parabola. My vertex is going to be positive 6 comma 0. That's my vertex. My a value looks like it's positive, so it's going to look like a parabola that opens up just like this. Now, this is just a sketch. And then, if the inverse graph, what is that going to look like? Remember, your inverse graph is a reflection in this line. Okay, so keep that in mind. So this graph is going to look something like this. I'm going to try really, really hard to sketch this really nicely for you guys. So we have a graph that looks like this. All right, so obviously it's not the best graph right there, but notice, does this graph pass the vertical line test? Well, if I sketch a vertical line through this inverse relation, you'll notice that it crosses at 2 points, so it's not a function. So I can't use function notation for this equation. So my final answer is just going to be like that. 6 plus or minus the square root of x is equal to y. In other words, the inverse of my given function. So that is it for this lesson.